So I have told you yesterday that what is isomer mean. Isomer is actually a term which is mean that we have same molecular formula, but different structural formula. Okay, but different structural formula. You have to remember this definition. It is quite important according to paper 2 and paper 1 as well. So you have to learn this. Okay, I have shown you yesterday that how we can draw the different structural formula, but according to our syllabus, we just have 2 examples. Right now, we are moving towards butane, and then we will proceed towards pentane. Okay, just have 2 examples for alkane members. We just have 2 examples, butane and pentane. So starting with butane, we have 4 carbons, right? 1, 2, 3, 4, and every carbon has to fulfill its four valency, having 4 bonds. So it has 4 bonds now. It has 4 bonds now. Now these 2 also have 4 bonds. Okay, so in this way they are completed their valency. Okay, so this is the linear structure. For your ease, I'm just going to draw it a condensed form. It is a condensed formula, so it is easier for you. You can see in this way that if I highlight over here, this is the first carbon having 3 hydrogens, which is just like over here you can see CH3. Then second carbon with 2 hydrogens, it is CH2. Then third carbon with 2 hydrogens, it is CH2. And the last carbon with 3 hydrogens, it is CH2. Okay, so it is a linear chain, it is a straight chain, it is a one raw chain, it is a one go chain. So it is linear chain. Okay, so whenever we have a linear structure, that is a straight chain, and it is maybe just like, for example, I just write the last carbon in this way. For example, I just write last carbon in this way. So it is one go chain. Okay, this is a single structure. Okay, it is like that. You can see that it is one go structure. Okay, so it is linear chain. Okay, you can put your finger on the first carbon, and you just, without putting up your finger, you can go from one carbon to the last carbon. That means it is a linear chain. Okay, it is unbranched structure. Okay, it is what? It is unbranched structure. Okay, boys, it is unbranched structure. It is maybe just like this. For example, I just put the first carbon on the top, second carbon. So it is again, it is a linear chain. Okay, chain as well. Okay. So for example, like if I just put like this, the first and last carbon on the top, so it is again a linear chain. For example, if I put the first carbon on the top and the second and then third and the last carbon in the bottom of the third one, so it is again a linear chain. So all are linear chains. You can go in one go. Okay, you can go like this. This is a linear mean. Okay, without putting up your finger, you can start with the first carbon and you can end with the last carbon in one go. That means they are linear structures. So they all are linear structures. The first one is linear structure. It is linear. It is linear. It is linear. It is a linear structure. It is linear structure. By the way, these two are same. First one is full structural formula. It is a full structural formula, and it is like a condensed formula, which is actually a structural formula. Okay, so we have 5 different structures right now, and all are same. They all are same structures. They all are linear structures. There is no difference in any one of them. They all are same. So they are not isomers of each other because they are same structures. They are linear structures. They are unbranched structures. So they are all same. Okay, boys. But what is if I write one of them in this way, just like this? So this is something else. If you go like, I'm just writing in two ways. Okay, you put on the first carbon, or if you put up, or if you put down on the second carbon, it is a same thing. Okay, so if you go in one go from first carbon to third one, there is a space on second one. You cannot go even all the four carbons in one go. That means that is something else. Okay, if you go like this, first carbon, second carbon, or third carbon, so in this way this carbon will remain out. Okay, so this is the linear chain, which is known as a branch structure, which is known as a branched structures. They are branched structure. Okay, they are different. Okay, so this is a main chain which is formed in one go, and the one which remain outside the chain is called branch. Okay, so whenever we name any organic compound, so what we have to do actually, we just have to identify the branch and the number of carbon on which that branch is. Okay, so you can see that this branch is either, if I start from this carbon, it is on second one, or if I start from this, it is again on second one. So I can start from anyone, from anywhere, like from first carbon or the last carbon. On both sides, the branch is on the central carbon. That means it is on the second carbon. So I can identify this branch like this. It is on second carbon, and the name of branch is methyl. The name of this branch is methyl because we know that meth means one carbon, right? Meth means one carbon, and we have one carbon in this branch, so we can call this branch as methyl. Okay, and this methyl is on second carbon. Okay, so we can write like this, it is 2-methyl. Okay, we just need to show that methyl is on which carbon, so it is on second carbon, right? So 2-methyl. And how many carbons we have in the main chain? We have 3 carbons, so it is prop for 3 carbons, and we all know that they have single carbon carbon bond, so it is propane. So the name for this compound is 2-methyl propane. Okay,
Okay, sir.
if you see over here, it is 1 and 2 carbon. Like on second carbon, it is methyl branch, right? It is a main chain. And on the second carbon, if you start from here even, so it is again on the second carbon. So the name is same, either you draw in any way, 2-methyl propane. So that means these two structures are same. Okay, these two structures are same, and these 5 structures are same. All the name of all these structure is actually butane. They are linear butane. Okay, so this is butane and this is 2-methyl propane. Both are different from each other, but the number of structures on the same slide are same. Okay, for example, these two structures are same and these 5 structures are same, but if we compare both of them, so they are different. Okay, but the main thing is the molecular formula. The molecular formula for all these 5 structures is it is C4H10. You can count if you want. Okay, all structures having 4 carbons and 10 hydrogens. The molecular formula is showing the exact number of carbons and hydrogens over here. So the molecular formula for all these structures is C4H10, and even the molecular formula for these two structures as well, it is C4H10. So the molecular formula is same, but the structure are different. We have 2 different structures. Okay, we do not count them 7 structures because I have told you that they all are linear structures, so they are same. They all 5 structures are same. Okay, and these 2 structures even are same. You can see or verified it by the name as well. Both the structures are same, but it just looks are different. Okay, it is just like that. You are Josefa, you are same Josefa before cutting your hairs and after cutting your hairs. You just have a new look when you just take a go from your barber, but you are exactly same as you are previous. Okay, so they are same, but just give you a different look. Okay, so we just have two different structure. One is butane and second one is 2-methyl propane. That is why they are isomers. Okay, so these are actually two structures. If I draw like this, so it is not wrong. Isomers of butane. If someone asks you write or draw the structures of isomer of butane, so it is just like this. It is simple butane. You can add hydrogens over there. Okay, and this is methyl propane. You can add hydrogens over here. Okay, so we just have two isomers of butane. Okay, we have two
Yes, sir.
isomers of butane. That's all. But I just show you all these structures just because of that. In the MCQs or in the paper, they can draw like that. So you need to understand this, that they all are same. Okay, and nothing else. And the one thing that I want to share with you guys is if I draw the structure of propane. For example, if I draw the structure of propane, it is CH3, CH2, and CH3, right? So if you put the last carbon on second carbon, or if you put the first carbon on the second carbon, the structure will remain same. Okay, the structure will remain same. It is linear, it is linear, it is linear. So there is no way possibility to form isomers. Okay, so that means when we talk about isomerism, so actually isomerism start from butane, right? So you can say that we have only one structure for propane, right? We have only one structure for propane. We cannot make any other structure of propane. It is quite same. It is remain same. Just give you a different look. But when we talk about butane, so we have two isomers, right? We have two structures. So definitely you can see that when the number of carbon increase from propane to butane, we have one more carbon. So we have one more structure, right? But if we have one more carbon in the chain like pentane, so definitely we have one more structure. That means we have three isomers in pentane, we have two isomers in butane, and we have only one structure in propane, ethane, and methane. Okay. So if the examiner asks you in the exam that how many isomers are there or how many possible structures are there in hexane, so you can easily answer it is possible that hexane has four structures. Okay, boys. So whenever you have an increment of single carbon in the chain, so definitely there will be a single increment of structure, possible structure isomer in the chain. Okay, boys.
Okay, sir.
Okay, so let's move towards the isomers of pentane. It is also in your syllabus, so we need to talk about this as well. So if we talk about pentane, so pentane, we know that it is a belongs to alkane family. So general formula is CnH2n plus 2. So if I put 5 over there, so it will be C5H12. The molecular formula will remain same for all the structures. So let's draw the first structure. First structure is actually simply it is pentane. Right? It is just like this. Simply pentane. I have told you if you want to put the first and last carbon on the top, so it is possible. You can put it. It is linear chain. It is same. If you want to put on the last carbon, it is again, it is same. It's not a different task or it is not a different structure. It is same. It is just like a different look, but it is same. If you want to put like this, so you can CH2, CH2, CH2. You can put even if you want to put like this, so it is again same. If you want to put like this, you can give any structure, but it is linear in all the way, right? It is same. All the structures are same. They all are linear because we all know that they are in one go. It is a one go. It is one go. It is one go. It is one go. It is one go. So all structures are in one go. You cannot even need your finger to put up when you start from one carbon to the last carbon. So they all are linear structures. They all are same. This means a single structure. This is the only structure. It is just like that. In this way, you are Josefa and Abdullah. What, for example, if you talk about Josefa right now, Josefa is standing over here, but Josefa is still Josefa. Over here, Josefa is going to exercise. He is exercising, but still he is Josefa. Over here, Josefa is like sitting, but still he is Josefa. It is Josefa who is lying on the bed, but it is still Josefa. For example, it is Josefa who is playing somewhere, but it is still Josefa. We have just different looks, but it is still the same structure, right? So all the time we have same structure if we put last carbon on the top or on the like below or in the bottom, it is remain same. So be remember, if the last carbon is shifted to upward or downward, it is remain same. But the thing is that if you want to put a last carbon on the not if you want to put the first or last carbon on not second last but third last, it will change into branch, right? So it can be have a second structure like that. For example, I'm just removing this one. So for example, we are talking about second structure of pentane. It is just like that. For example, we have like this. I'm not putting last carbon on the second last one. I'm just putting on the third last. Okay, so it will be like that. It is a branch, a structure. If you go in one go, you will go with 4 carbons, and this carbon will be remain outside. So this will be branched isomer. And what will be the name? Just be remember the main chain has 4 carbons, so it is butane, and we have methyl functional. Sorry, we have methyl branch, so we can put methyl over here, and you need to identify on which carbon methyl is. So be remember, from where branch is near, we need to start numbering from there. Okay, so it is 1 2, so we need to start numbering from here because branch is near to this carbon. So it is 2 methyl butane. Okay, you can put it over here. It is doesn't matter. Okay, you can remove from here and you can put onwards. That's okay, not a big deal. It is remain same. Or if you want to put this methyl functional group, or sorry, branch over here, up or down as you want, you can put anywhere else. So you can take like that. Even it is a linear chain, but it is still outside the chain. So it is same. You can start numbering from here because it is the branch is near from this carbon. So it is again 2 methyl butane. Only the look changes, but the structure remain same. So that means both are same structures. So this is the second isomer of this is a second isomer for pentane, right? For third one, you can draw even the third structure for this. And how can be this one? It is just like that. We have CH3, C, CH3, and we just put 2 branches. Just put 2 branches. So you can go from first carbon to third carbon in one go, but you can not take in this go the up and down methyl branch. So that means we have 2 branches now, and both the branches are on second carbon. So you need to identify both the branches, that we have 2 branches and both are on second carbon. So when we have 2 methyls, so we can use di word. The word is di, means 2 methyls, right? We have 2 methyls, so we can use dimethyl. Okay, and the long chain contain 3 carbons, so it is propane. So we have 2,2 dimethyl propanes. Okay, if you're still confused, so we can do like this. You can take like this as well if you want to take a long chain like that. So you can, it is a long chain, right? And this is a branch and this is a branch, and again it is on the second carbon, 1 2. So both branches are on second carbon, so the name is again same, 2,2 dimethyl propane. But still, if you are confused, so you can take another example like that. if you want to go in one go in this way, so you can even go in like that, 1, 2, 3 carbon. It is just like that, but again, to left, and in both of cases you have branches on second carbon. Again, the name it still remains same, which is 2,2 dimethyl propane. That means all these three structures are same, right? And examiner can disturb you in this way, that we have 5 carbons, and every carbon has 4 bonds. So examiner can disturb you in this way, I'm just showing you with different color. We have 3 hydrogens with every carbon. Don't be confused, please. It is isomer of pentane. So it is just a full structural formula, right? So they even disrupt like that, students. In this way, they draw the structure like way, and the student got confused that what is this and from where it came. So you just need to understand that it is a full structural formula of 2,2 dimethyl propane, and it is the isomer, and it is the third isomer of pentane, and all these structures having the formula of C5H12 with different shapes and different structures. This is the second structure. This is the first structure. It is like unbranched structure. It does not have any branch, so it is unbranched structure. But if you see this structure, so it is one branch structure, right? We have only one branch over here in this structure. But if you see the third one, so we have 2 branches over here, and it is 2 branch structure. So we have 3 different structures for pentane, and these are isomers of pentanes. Why we call them isomers? Because we have the same molecular formula, which is C5H12 right now, and we have different structures. Okay, boys. So that is the isomer for pentane and butane right now. Okay, is that clear?
Yes, sir.
Any confusion in this?
Not too much.
Okay, so you need to review this. Okay, it is quite important. You need to revise this. We have 2 isomers structures in our syllabus about alkanes. Number 1 is butane, and number 2 is pentane. For propane, we don't have isomers. We just have a single structure. But when we move towards butane, we have 2 structures. When we move towards pentane, we have 3 structures. Definitely, when we move towards hexane, heptane, we have increment in the structure or increment in the isomers. You need to remember this point as well for MCQs, and you need to practice these structures for past paper questions in paper 2 and paper 1. And definitely, we are just talking about right now isomers of alkenes. We are not talking about isomers of alkenes. Definitely, they have a number of carbons and functional group as well. So there will be increment in isomers over there and the possibilities over there. So we are not talking about that right now. We are just talking about alkanes right now. Okay. When we talk about alkenes in the next upcoming days, so we'll talk about that as well. And you need to remember this, that isomers having same number of carbons and same numbers of hydrogen, and that means they are having same number of electrons. Okay, and we need to remember this, that chemical properties are due to the electrons. Chemical properties are due to the valence electrons. So that means isomers having different structures, definitely, but they are having same chemical properties because they are having same number of electrons in the outermost shells. But definitely there is a difference in structure. So structure depends, physical properties depend on structure. So when we have 2 different isomers of butane, so they have different physical properties. Definitely boiling point, melting point different from each other, but chemical properties will be the same. Okay, you need to remember this. Okay, boys.
Okay, sir.
Okay, so take care of yourself. Inshallah, we'll see you in the next class. If it will be Saturday, so definitely I will inform you all. If it is not, so we will see you on Monday. Okay.
Okay, sir.
Take care of yourself, boys. Stay safe, stay blessed. Allah.